I mean, if we look at any of these and we say that, this one here, it's got a city on it, that's got a town. And if we say that each edge is a vertex, and then this city in the middle is also a vertex, then we have at most 6 vertices that have to do with the grid, which will of course overlap with adjacent tiles, and then up to 2 vertices that are in the middle of the tile. Now, different games have different things going on. Some of them actually have a stop at every single side of the piece, which would mean that depending on how you're mapping this problem out, you could have 6 vertices, 1 for each side of the piece, and then 6 more vertices in the middle of it, 1 for each town in the piece. 1830 only has at most 2 towns. You've got your double towns, you've got double cities. And then you've got something like New York, which is a special double city. Baltimore, Boston, those are special single cities. So you'll know exactly how many you've got in each one of these. And let's see, where was I going with this? Oh, right. The unoptimized way of doing it would just be to say that, okay, we're creating some sort of, we're creating a generic object for all of these. It can connect up. We could even use some sort of linked list or something like that, link to other nodes, where each one of these links to, adjacent tiles, and then it has 2 spots for cities in it or whatnot, however we want to do that. And then the optimized way of doing that, we could just have a list of, the cities in the game. I don't know what the best way to map the problem is. That's actually part of the problem. There are 2 problems. The first problem is, what's the best way to map all of this out? The second problem is, using that mapping, what is the best way to figure out the runs involved? But the assumptions that can be made are that if we ignore that vertex contraction, that absolutely nothing will ever be subtracted. We start a new game, we start with nothing, and then we build from there. And all we're doing is we're adding edges between vertices. We're never moving edges unless we have that strange vertex contraction, and we are certainly never moving vertices. I mean, sometimes these will be inaccessible. These towns right here, nobody can get to them right now, but that doesn't mean they don't exist. And so then what will happen is, when we're laying track, we have these, no, let me back up a bit and get rid of this grid. That's where I was going. So we have this land, mountains, water, and large bodies of water, you just can't lay track there. It's impossible. It doesn't happen. And then if you've got some land there, you can lay track there. You can't lay track into the water, and so that puts a restriction on the orientation of the track, and potentially even pieces of track that you're allowed to put down. Now, if you have smaller bodies of water like these rivers, that just means that it's expensive to put it down. I mean, it costs 80 to lay here, because that's the cost of putting a bridge, presumably. It's the same thing with the mountains. I mean, we can't move mountains, but we can move through them, as it were. So presumably this 120 is infrastructure for tunneling through the mountain, or for building, some sort of track that goes through a pass through the mountain or whatever. And so but these penalties that you're going to pay, first of all, they're paid the first time that somebody ever puts track down there. So after that initial infrastructure has been put in, it doesn't cost anything to upgrade. And then, I mean, this can exist on places that have no cities whatsoever, like, say, this mountain down here. I don't know why you'd ever go there. And then it can exist on cities. I mean, this one here, this city here, you're going to need to have to pay to put something through the mountain to get to that city. And so these penalties are, they're a penalty you have to pay to use that, to put a tile down on that location, but they don't have anything to do with the actual tiles that are allowed there. Surrounding ones, water does. These solid lines mean you can't put track that connects to there. And then what happens is, so we have these blank spots, and those get the regular track pieces that don't have any towns or cities. If it's got a double town on it, then you can only play double town tracks there. If it's got a single town, you can only play single town tracks, so you can't choose where the towns and cities go. They already exist, you're just connecting to them. And then the difference is you've got single and double cities, single double towns, and then regular track, and then you may have some special locations. This New York here is a special location, has its own series of special tile upgrades. We have the Baltimore and Boston, which again, they're special locations. The different games have their special different tiles. So we've got these different classes of tile upgrades that can be used. And that's, but those spots are all predetermined. And so if we go back in and we look at our remaining tracks, I mean, one potential, well, a side effect of that is that we can know exactly how many edges the game is going to need. Because these double cities here, even if we allow the vertex contraction, at most they will have 2 internal vertices and 4 edges. And then once they're upgraded, they go to 1 internal vertex with 4 edges, which is kind of odd. But then it's the same thing with the other ones. These single cities, they start off with, of course, 1 internal vertex and 2 edges, but that gets upgraded to 3 or 4 edges, and then it finally gets upgraded to 6 edges. So those ones will have at most 1 vertex, 6 edges. The double cities will have at most 2 internal vertices with 4 edges. The Baltimore, Boston, again, that's 1 vertex, 4 edges. New York is 2 vertices, 4 edges. And so what you could do, depending on how you want to map this out, is that you could actually figure out exactly how many edges it's possible to have in the game. The worst case scenario whatsoever. And then that might depend on exactly the type of model you want to use. And of course, the specifics are going to depend on the tiles that exist in your game. In 1830, regular track will consist of at most 4 edges, and then almost everything is at most 4 edges except for the single city, which has 6 in 1830. And then again, 1830 has at most 2 internal vertices for cities or towns.